Good morning and welcome to the Citrus Industry Stakeholder Engagement Meeting. This meeting is focused on the CitrusSprayEx Expert System. My name is Dr. Peter Kolabi, Assistant Cooperative Extension Specialist in Agricultural Application Engineering with the University of California Division of Agriculture and Natural Resources. And I am located at the Kenya Agricultural Research and Extension Center in Palia. This morning I'm not feeling very well, so I'm presenting this webinar from home, and I hope that everything goes well as we are looking forward to discussing the project that focuses on this expert system. The objective of just to give a quick idea, the objective of my position is to provide leadership in agricultural engineering extension and applied research with a focus on spray application engineering, mainly to specialty tree crops, including citrus, but also to other crops. Here is the abridged agenda for the meeting. I would be presenting on CitrusSprayEx Expert System, a decision support tool for planning and evaluating spray application engineering, and a new project that is focused on disseminating this tool to improve agricultural productivity while potentially reducing the frequency of applications. Now, through this meeting, we intend to gather your initial assessment and input so we could identify ways to better serve the industry need in this project. My presentation will be in two main parts. I would talk about the project goals and planned activities, and then demonstrate how the application is used under different scenarios. In order to engage you and gather your feedback, there would be polls that will show up on your screen, and I would encourage you all to participate when that time comes. We'll be ending with a time for discussion and additional feedback from you, at which time I'll be joined by my colleagues, Dr. Beth Grafton-Cardwell, Director at the Linkov Research and Extension Center, and Dr. Greg Duhan, Cooperative Extension Area Citrus Advisor for Tulare County. These colleagues are key persons on the project. For those of you needing continuing education units, we would need you to fully participate, and we encourage you to do so. So pesticide spray applications provide critical protection for crops against pests, despite efforts to reduce their use through integrated pest management methods, such as sanitation and biological control. Pesticide use remains inevitable in most cases. And this is especially true especially true for the citrus industry, which is facing the spread of Huan Longbing, or HLB, the devastating and incurable bacterial disease vectored by the Asian citrus psyllid, the ACP, which is seen here. Managing the pest with insecticides is key to slowing the spread of the disease. However, the complex nature of spray application under field conditions often poses a challenge to applicators, limiting their ability to achieve high application efficiencies. Here is a summary of data from Salyani et al. 2007, which indicates the variability of the outcomes from spray application in citrus. It's complex and can be daunting. And so, although the California Department of Pesticide Regulation, that's a DPR, requires individuals who use or supervise pesticide use to possess applicator certification, which means they become knowledgeable in about use and handling of pesticides. This does not necessarily guarantee that applicators will recognize or use best practices when faced with the complex field conditions. So how can we reduce use with low efficiency? That was a question we sought to answer when we responded to the DPR's 2019-2020 request for proposals under the Pest Management Alliance grant program. So the goal of the PMA grant program is to fund projects that use various systems to promote the voluntary adoption of IPM practices that will reduce the risk of pesticides to human health and the environment in agricultural and non-agricultural settings. What we proposed was a 3-year project aimed at reducing pesticide application frequency or quantity in citrus by increasing application efficiency using an expert system that leads the user to best practices of pesticide application. An expert system is basically a computer program that simulates the judgment of an individual or organization possessing knowledge and experience in a particular field. So basically, this is a computer application, or we can say an app. The existing expert system called CitrusSprayEx was designed to provide decision support for spray applicators who use air carrier sprayers, specifically air blast sprayers, to apply pesticides in citrus canopies. All right, so we would continue with the agenda. I would be talking a little bit more about the project. So the title of the project is disseminating and training for citrus spray expert system adoption in California. And our goal is to improve pesticide spray application efficiency in citrus and reduce general pesticide use in the San Joaquin Valley region of California. Specifically, we intend to cut the number of pesticide applications by ensuring effective pest control and reduce need for repeat applications through the adoption of an expert system that guides growers and applicators in correct calibration, suitable application timing, and proper adaptation of application techniques in different situations. So here are the specific objectives of the project. We want to initially make the current expert system freely available online on compact discs, the CDs, and on flash drives. And we also want to promote the use of the expert system as a planning and evaluation tool for spray application within the citrus industry. And then promote sprayer calibration as a best practice utilizing the expert system. And then to evaluate the expert system via fluorescent dye-based field spray trials. And then promote acceptance by the citrus industry by incorporating the expert system evaluation and feedback and field trial results to demonstrate the expert system based on spray application. And then finally, to promote the use of the expert system as an educational tool for agricultural students in one high school and one college per year. And this was added as an outreach from the project. So here are some details about the making the current ES freely available. So we plan to make the physical expert system available, and I would be reaching out to you to ask if you could indicate what type of media you would prefer. Whether I'm doubting there would be much request for CDs, but we have CDs, flash drives, and then also this would be made available on the project website. So it can be downloaded directly from the project website. So we include the project website as a means of disseminating information about the project and also getting feedback from people that would evaluate, or users that will evaluate the expert system, and also get some other information as in terms of questions and maybe user experiences with the expert system. The expert system we are given right now was designed directly for citrus. In the long term, we want to develop it for other tree crops and include various sprayers, and also so a user can select a crop type and also select their sprayer and include some other information that would be that would apply directly to their specific situation. So while we evaluate the current ES system, expert system, we would also be developing a web-based expert system that will be mobile friendly. So rather than needing to install the system, you can access it directly on a website, and that would be developed in due course of the project. So here are the processes we'll be following to complete that, and we hope to complete the expert system, the final system, which is the new system, early in the coming year, which would be 2021. We plan to promote the use of the expert system as a planning and evaluation tool for spray application. within the citrus industries. And this we'll do through expert system application workshops. During this workshop, we'll provide hands-on tutoring or instruction in using the expert system and how to use it effectively to for one's application. And we would provide provide computer stations if we happen to do this at a physical location. Currently, because of the issues with the coronavirus and the need to pursue virtual meetings, if that is possible, we would use this as a plan B if we are able to do this physically because of the need to reduce chances of the cases. We would need to do this virtually, and so that would be plan B, and we would be disseminating this information when it becomes available. That is what time for this workshop. So we plan to conduct 2 workshops per year, and at the end of the project term, we are looking at organizing a regional conference where we would showcase the new expert system and also get some feedback from people who have used the expert system, and also get some, basically provide a report of what we have achieved during the term of the project. We also want to promote the sprayer calibration as best practice. And in addition to the workshops, we plan to conduct 1 sprayer calibration training a year, and this would cover all aspects of the of calibration, and would utilize the expert system as necessary during the calibration. And then we also plan to evaluate the expert system with a fluorescent dye-based field spray trials. This means that we would be using fluorescent dye in solution and applying that to our target tree canopies, and then we'll collect data. We'll collect the samples and run the samples in the lab to evaluate spray deposition, and we plan to use a combination of nozzles and speed. So we have 2 nozzles, 2 nozzles settings, and then 2 speeds, and we can include others. But this is the generally the type of randomization we would be using for the spray trials. And then we also plan to promote acceptance by the citrus industry. by incorporating the expert system, evaluation, feedback, and field trial results to develop and improve expert system, and demonstrating the expert system based spray application outcomes at field days to show the levels of deposition and coverage achieved. So we would be using the success of using the expert system to encourage acceptance of the expert system, and in view of that, we actually would be promoting the acceptance of the new expert system that will be developed based on all the feedback and all the evaluation that we would be doing in the course of the project. So at the end of the project, we would have an extensive expert system that would be accessible and also available to everyone. Okay. So we would have one field day each year of the project, meaning 2020 would have one, and then 2021 we would have one. And we also plan to promote the expert system as an educational tool for agricultural students, as I mentioned earlier. We will be targeting one high school and one college per project year, meaning 2020 and then 2021. We will cooperate with schools in the North and South Valley, one high school and one college each, to integrate the expert system maybe into a course of study, or to integrate that as a special program or something that will engage the students in spray application issues, and use that to as an outreach tool to reach out to them. This integration will enhance teachers' course offerings and enrich student understanding of spray application issues in citrus. So we plan to have one outreach, that is one outreach for maybe a high school and also a college, and an outreach for a high school and college in the following year. So these are the locations that we are planning to cover during the course of the project. So that is an overview of the project and what we plan to achieve during the course of the project. Now, I would want to call in a new poll. So I'm pulling up this new. Okay. A new poll will pop up before you right now, and I would encourage you to complete the poll. I'll wait for more responses to come in. A few more responses outstanding. Okay. I would be closing the poll in a few seconds. Okay, I'm closing the polls now. All right, I'll share the results with you right now. And basically, I thank you very much for your responses. We would have time to discuss this as the last item on our agenda. So I'm hoping that we can, there will be a few things to add or feedback to get from people as we discuss for feedback. Thank you. Okay. So I think we are a bit running fast. So that is a good thing. At this point, I would want to move on with a demonstration of the expert system, the current version, and then again, the current version, we are disseminating it as an initial form to get your feedback, and then based on the feedback, as we develop the new system, which we intend to make it web-based and also mobile friendly, we hope that we would be able to come up with something that would be much easier to use. Yeah. So at this point, let me move on to the demonstration. And I present this here as a scenario, but I would come back to this. I would come back to this. So this is a scenario that I'll be running through on my slide, that I'll also be going on to use the expert system itself to demonstrate. So this is showing that you maybe someone, a grower has made adjustments to their airblast sprayer and are planning to spray a citrus orchard, and so realize the need to calibrate the sprayer. The sprayer has 10 nozzles per side, but based on tree height, they'll be using 8 nozzles per side. The orchard has 20 feet row spacing and 15 feet tree spacing within each row. So the recommendation is to apply 100 gallons per acre, and the travel speed being considered is 2 miles per hour. So this is sort of a scenario that I put here for us to explore the expert system. And this is also another scenario for spray timing, and as I get into it, we would understand how that works. So you have calibrated your sprayer and ready to apply a recommended pesticide. Should you not spray under the following conditions? So these are a combination of temperature, relative humidity, and wind, and also consideration of rain being expected. And these are different combinations to see if it is important, it is necessary to go out and apply spray or not. So here is the expert system, how it looks like. Just a quick idea. This was developed during my PhD at the University of Florida, and we evaluated it briefly, but we could not get it. The opportunity was not there at that point to continue a full-scale dissemination and also get feedback to improve it. So this is the opportunity to do that, and also to make it useful for end users. So this is what you would meet when you start the application. You have spray planning and spray evaluation. Spray planning basically leads a user to in spray calibration and also spray timing. And in the spray evaluation would require a user to make inputs about a spray application scenario, and then run a simulation to give estimates of the outcomes from the spray application, outcomes of deposition, spray deposition, canopy deposition, ground fallout, and also potential drift. When you click on the spray planning, this is what comes out. You have calibration versus timing. And then when you click on calibration, you have these different tabs: calculate speed, select nozzle, and calculate sprayer output. And these are basically leading a user through the calibration steps. And you notice that the system can be run in metric units or English units. So this is what it looks like when we come to the calculating speed. This gives the opportunity to use two methods. We have a known distance method, and we have the tree pass method. Depending on which radio button is selected, the relevant fields will be available for entry. So with a known distance method selected, we do not need a tree spacing, we do not need the number of trees. So you can see that these are deactivated. And then if you go to, if you select tree sparse method, that will open up new different fields. So with the tree sparse method, the travel distance is deactivated, because the travel distance will be calculated using the tree spacing and number of trees passed. So let me step back and give an explanation here. So with the known distance method, in performing calibration, one of the first steps that is needed is to determine the speed of your sprayer. Determine the speed of your sprayer, and that is done by running the sprayer across a known distance and determining the time it takes to travel that distance. So that is what this depicts here. You focus on one a fixed point on the tractor or the sprayer, and calculate when that fixed point reaches the starting flag, and then the time between that point reaching the starting flag and reaching the ending flag, and then the known distance divided by the time. Okay, so that is what this does here. 100 feet. 100 feet and 200 feet are typical distances that are measured, and this is usually done in the field where the application would be done, in the orchard or near the orchard where the application will be done. And when you make the entries and click on calculate, it gives the speed of travel, the speed that the tractor, or the sprayer is traveling. And one other thing too is that in doing this, the sprayer needs to be, the tank needs to be filled to about half, so that the tank needs to be filled to about half, when doing determining the speed, so that it accounts for spray liquid in the tank. With the speed calculation, with the trees passed method, the number of trees passed, we use the tree spacing. We use the tree spacing, and then the number of trees passed to calculate the speed, the distance, and then the distance divided by time, and converted appropriately. One thing to note in this case is that the first tree is not counted. So in this case, we have 5 trees because we are looking at the spacing. So we have 5 trees, 1, 2, 3, 4, 5. So 5 times the tree distance. So whichever one is used in your case, that is entered or input into these fields and pressing calculate will give the speed that the sprayer is traveling. Once speed is determined, the next thing to do is to select nozzle, and this is what it looks like. These are the inputs required. The tank makes specific gravity is included here to account for the actual pesticide mix. But usually we do calibration with water, and so this can remain 1 for that purpose. You have desired gallons per acre, that's application rate, and then the desired travel speed, or the measured travel speed, and then row spacing, and then tree spacing. Sorry, row spacing, and then the number of nozzles open, and we can choose either uniform or non-uniform. Uniform means that all the nozzles per side should deliver the same amount of spray, and so the same nozzle will have to be selected. If we use non-uniform, we can determine the what percentage of the spray we want to deliver to the top, and what percentage we want to deliver to the bottom part. So a typical what you call division is, we have 2/3 to the top and 1/3 to the bottom part. And so once you select non-uniform, you enter the percentages, and then make the other inputs, and this will, when you click on calculate, it will give you the it will recommend the nozzle combination to use. Now, in this initial expert system, we have only disk and core nozzles from TJet, but in going forward, we would be including other nozzles from other manufacturers. So one can have recommendation across the board. But at this point, it says, gives the recommended nozzle, and then also asks to use equivalent nozzles from other manufacturers. So at least this takes care of that. But in going forward, we would be including nozzle from other manufacturers as well. So this is the other input using non-uniform spray, 66.7 to the top and 33.3% to the bottom in this particular case. And the number of upper nozzles would have number of upper nozzles and lower nozzles will have to sum up to the number of open nozzles per side. And then operating pressure is also indicated. And then this gives a recommendation for using like D4, 45, D5, 23. So gives you recommendation for the top nozzles, that's the upper nozzles, and a recommendation for the lower nozzles in order to achieve the desired application rate. We have what do you call it? Calculate. Once we have determined the nozzles, we have selected the nozzles. We have the recommended nozzles, and we have fixed them to the sprayer. Then we have to determine we have to measure the flow from the nozzles. The catalog usually gives the expected flow for each nozzle, but when you actually measure it, you don't always get exactly what the catalog says. So in calibration, we tend to measure it. In fact, we have to measure the flow from the nozzle so that we can use that to calculate the application rate and adjust appropriately. So there are different methods that we can use. We can use a known area method where you apply the spray to a known area, and then you will use the amount of the volume that was sprayed out for that area divided by the area and converted appropriately to have your gallons per acre. We can have actual area known, or we can use row and tree spacing. And then we also have the fixed position method where you apply spray in a fixed position, and then you will you apply spray in a fixed position, and then you will measure out how much you deliver per certain time, and then you use that to determine the flow from the nozzle, the spray. Now, on the other hand, moving away from calibration, once you're done with calibration, this has to do with timing, whether it's okay to spray or not. And this can be done before the application, or even in the course of the application when conditions change. This can also help to advise the applicator. And in going forward, we intend to use real-time weather data, and also we plan to incorporate GIS maps, so the data can be rather than the operator or the user making the entries, the system can be checking automatically, and would give notification based on changes occurring in the weather. So this would be at this stage, you have to enter the weather parameters and then find out if it's okay to apply or if it's not okay to apply. And then this can be done before the application. This can be done in the planning stage. You make the entries based on the weather forecast, and then you check if it's okay to spray. And this makes a determination based on, you know, the weather, how much dryness we have, and if the weather is dry, that is high temperatures, low relative humidity, those would be increasing the rate of evaporation, droplet evaporation. And by increasing the rate of droplet evaporation, it means that the chances of the application being very effective are going to reduce. And also, we have a range of wind that is acceptable for or suitable for spray application. So it uses all this combination to give feedback. So in the previous entries, the conditions are okay, but subject to rain wash off because of the rain being expected within 2 hours of application. So in this case, for instance, one can use a fastener that would an adjuvant that would increase fastness of the spray droplets to the leaves, and thereby reduce the chance of washing off. And in this case, with all these inputs, it's too dry and there's high potential for droplet evaporation. So this is not recommended for application. And these conditions says it's okay. You have you know, a combination of temperature, relative humidity, and wind speed. These conditions are okay and favorable for performing spray application. Here is another combination. It's too cold, and application is subject to rain wash off because of the rain being expected within 2 hours after spraying. Okay. So at this point, let me open the application and actually show you Give me just a moment, please. So here is the application. Here is the application. And so this is what it looks like. And as I mentioned, the depending on what you select, the irrelevant fields become deactivated, and then you can enter. So this gives a user the opportunity to decide which method to use in calculating the speed. Let me say okay. Okay, so that's how it appears. You know, depending on what you choose, you can do run the. And this is the nozzle selection part. And then the sprayer output determination or calculation. This is the timing. So as you, for the timing, as you make the entries, let's say you have just one, one parameter. It will give you a response based on that one parameter, and then would change as you make other inputs. So let's say you have no idea about the rain, you can it will give you a recommendation based on what you know. All right, I would change over from here. I would come back to the spray evaluation part. But before I do that, I would go back to the presentation. And okay. So the one may ask about the expert system. The planning part was actually added to this expert system later on as we were developing the expert system, or the application. And the main part, which is the innovation part is the spray evaluation portion, which is based on a model. The model does calculation, the physical calculation of the spray based on all the necessary parameters, and then does a simulation and then make the estimates based on the simulation. So this is just to give a quick overview of that portion before I get back into to do the demonstration. So the spray model, these are some aspects of it. This is a Forrester diagram that gives an idea of all the different processes that were considered in building the model. This also gives the idea of the spray dispersion as the spray moves away from the sprayer outlet. There is expansion both in the horizontal and the vertical dimension, and those are accounted for. And for the spray, at the point where the spray, the interface of the spray and the ground, there would be ground deposition. And then there's also ground deposition occurring within a canopy when the spray is intercepted and there is runoff from leaves. This gives an idea of how the spray cloud was compartmentalized or simplified for the simulation. And within each compartment, as the spray moves from the outlet away from the outlet, we have the air velocity decreasing and decreasing drastically and then further decreasing gradually as it moves away from the sprayer. At the same time, we have an expanding compartment as the spray moves away from the sprayer's outlet. And this also shows the idea of how the droplet sizes were simulated based on the nozzle that is being used and the other parameters. And then also evaporation, droplet evaporation, how it was considered in a model. Droplet evaporation was accounted for as the droplets move from one compartment to another, and it was also accounted for as the droplets remain aloft. That is, as the droplets remain airborne. So this figure here is the basis for formulating the model equations that were solved to simulate the spray. So this is a compartment outside the canopy, which means that you only have droplets in air, and it's showing the processes that are taking place as the compartment, as the spray moves from one compartment to another. So we have inflow, outflow to the next compartment. We have evaporation taking place here based on the environmental conditions. We have drift, potential drift, that is spray leaving the compartment. And we have ground deposit based on ground interception and so forth. And then we also have within the canopy simulating the interaction of the spray with the leaves or the canopy components. We have deposition on leaves. We have ground deposit plus runoff from leaves. Okay. These are some simulation, individual simulations from the model, and this shows air velocity, variation in air velocity based on air flow rate. So the higher the airflow rate, the higher the starting velocity, but the trend is similar, decreasing gradually, decreasing drastically, and then further decreasing gradually as you move away from the sprayer outlet. And then this also shows the variation in droplet characteristic, that's the spray quality between different nozzles. We have a smaller nozzle, D213, and then all the way to D646. And this shows the effect of droplet size, the effect of nozzle size on droplets, or effect of nozzle size on droplet characteristics. The point where this vertical line touches the x-axis represents the volume median diameter, which is used to describe the spray, because for each nozzle, the spray that is produced has a range of sizes. So we use volume median diameter to determine, to describe or characterize the nozzle. And the higher the volume median diameter means that the spray has more larger droplets, and the lower the volume median diameter, it means that you have more smaller droplets in the nozzle. And then we also have some simulation of droplet size variation over time. And this is based on the weather conditions. So this is just to give an overview of what the model does, or some of the individual outputs from the model. But these outputs are not necessarily displayed or shown in the expert system graphical user interface. So going forward, we could determine if we could include some of these outputs. so a user can understand, or maybe an advanced user who wants to have these other outputs can have them and use them for their purposes. Otherwise, we would stick to what the nozzle, what the expert system currently gives. This is showing the effect of different weather conditions in the simulations, which means that changing weather conditions are accounted for in the model simulation. The model was validated with field data, and we validated it in 2 steps. The first was to validate it for dispersion, that is to see if the model is able to capture the spray amount at different points away from the sprayer. And we used a PVC structure to quantify or to collect, to sample spray, and then make that determination. Then we had a deposition validation, which was used to quantify spray deposition on an actual tree canopy, to see if the model is able to make close predictions. And so these were used to find or to establish to what extent we could depend on the model. But without the model, there is no way to actually guess. So these are some validation results, and I'm not going to go through it individually, but the markers are the measured results, and the curves are the simulation results from the model. The right images or figures are for the deposition validation. So based on this, we established that the modeling efficiency was 78% in the for dispersion, and 61% for deposition. And so this gives us, I mean, it would have been nice if this could increase a little more, but these values are pretty much good indicators that the model makes predictions close enough for us to be able to use. So it is based on that assurance, or that confidence, that went ahead to build the expert system to run based on the model. So these are components of the expert system, and this is one of the flow diagrams to show how the expert system is used. This is the interface, and I'll be showing that very quickly. So this is what the interface looks like. And this expert system asks for inputs of application parameters. Currently, the sprayer make, there isn't any sprayer variation in it. There aren't different sprayers. We did originally used a rear sprayer, so the values are based on that. But going forward, the idea is to generate data from other sprayers and to include those in the expert system. So a user can pick a particular sprayer that they are using, and then the settings would be based specifically on that sprayer. So we have the these inputs, the application parameters that are used for computing the for the simulation. We have application parameters. We have tree characteristics. We have the orchard condition. We have weather parameters. So we can keep the air outlet width as fixed because this was a value we had measured from the rear sprayer. So currently, this can be changed for different sprayer. If you're using a different sprayer, you can change this value, and you can also change this value. Okay. The airflow rate, this would be the rating for the sprayer, and then the nozzle. I mentioned that we have only this can call at the moment, but we'll be populating it. You know, in the new expert system, we would be populating it with other nozzles, nozzles from other manufacturers. So we can select a nozzle. This is for a uniform application. Let's say we have 8 nozzles, upper nozzles, let's say 4, lower nozzles, let's say 4, operating pressure, let's say 100 PSI, ground speed, let's say 2, tree height, we can leave it as it is, head height, we can leave it as it is, canopy diameter, we can leave it as it is. And then foliage, we did measure, we did look at different canopies, citrus canopies, basically orange trees, and we established values for a low foliage density, medium foliage density, and high foliage density. So these values are currently not fixed. These values are currently fixed for for low, medium, and high. So I'll say, a user would use their discretion, but we would also be providing a better direction for identifying whether the foliage density is high, medium, or low. We would also be exploring a means of measuring it. So this is what it gives you. You have number of trees per row, number of rows, tree spacing, row spacing, and then if there are any missing trees, then you have your weather parameters. So all these parameters are used in doing the computation. So if you click on simulate, so it gives you, it runs the runs the computations. So once it runs the computations, it gives you an output. And if you remember, I showed all the some outputs we could get from the running the model, but we simplified the output in this interface, so we can just have percentage canopy deposition, percentage ground fallout, and percentage spray drift. And this, I would say, is potential spray drift, because the computations are made within the orchard and not beyond the orchard. So this currently looks at potential spray drift. So if we were to change the foliage density, for instance, to medium and run this again, so this gives you new values, and we can see from here that the change we made was from low foliage density to medium foliage density, and the canopy deposition has changed from 52% to 71%, and then ground deposition from 3. There was no change here, and then drift, potential drift has moved from 45 to 26. So any change that you make in these inputs, it will give you the new values and tell you what has changed, and what resulted from what has changed and the effect it had on the outputs. So that's about it for this, and we hope to go beyond. If we need to add on other inputs, or if we need to add on other outputs, we will be looking at doing so in the improved version. Okay. So at this point, I would want you to please take this new poll, and this is to get a quick response feedback from you. So I would encourage you to please take this poll. And then I will give a few minutes to complete this as we get close to doing our discussion. Let's give a few minutes to complete the poll. All right, just we'll give some seconds to see if other responses are coming in. Okay. Thank you for your feedback. We're in the poll now. All right, so we actually now at the discussion, and let me correct that. At this point, I would have Dr. Beth Grafton-Caldwell and Dr. Greg Duhan to join me. And I would say if you have any feedback or questions for us, these are the questions we would want to be discussing.
Yeah, go ahead and unmute yourself if you would like to make some comments on the project and provide some suggestions for additional information that it should provide or other ways to do the trainings. We're not hearing anyone.
Okay, we have a few
some comments. Yeah, there you go.
A few comments.
I think you have people muted.
There's one that popped up in the chat box.
Yeah.
About availability, I believe. I think I saw.
So are you reading the chat box, Peter?
Yes, I'm reading what is coming in. Right, there were some other chats earlier on, but I think those do not relate to the.
Right.
Yeah.
Start with the download one, even if you've already said it, reiterate. Will they be able to download the spray evaluation chart?
Okay, I have a few things here. Someone reads that as a PC, I would designate a desired ground speed for the application and have the driver adjust gears and RPMs to achieve that. Your logic would have the driver set his ground speed and other variables must be modified following that. I suggest the ES accommodate both options. Okay. Thank you very much for the for that feedback. Yes, another question is that is a download available for this spray evaluation chart? Yes, we would be. I'll be sending the download information later on, but yes, it will be available freely for use. And then there is a comment here that initial assessment is that it needs to be streamlined and put more into an app type of system. It might scare folks off in this particular form. Okay, yes, and that's really why we decided to move this into or develop a new system for it and make it web-based and mobile friendly. So it will be an sort of an app which can be accessed using a mobile device or using a computer. So whichever media option you want to use, you can still access it. And so the initial form is what we had to start with, but based on the feedbacks and that we would get from users, we would be including those feedback in the new version that we are going to work on. And there is also a comment on the appearance, that it's too busy and will be confusing for many folks. Yeah, sure. So we would be getting. I don't know if the person who wrote this would want to maybe explain a little bit more, or otherwise we'll just take it as it is, and we would be improving the appearance with all the inputs. We would be improving the fields, and would also be improving the outputs from each of the screens.
The way you have the Zoom chat set up, I assume they can only talk to you through the chat room. They cannot talk directly through their microphones.
I think they should be able to talk through the microphones. Okay, let me.
How would you like, for people who have specific details, would you like to give your telephone number or something so that they can talk to you directly?
Yes.
Some of the questions or answers might be too detailed for a group discussion today.
Okay, yeah, sure. My contact information was included in the meeting invitation, so people can get back to me, or they can contact me, and or send an email if you want to write it out in more detail, or maybe call me. I have a question here, a comment here, says that this is an extremely complex topic when you include all the variables like sprayer configuration, nozzle type, and so forth. I feel your first goal should be to correct common errors used by many applicators and save fine-tuning for more advanced classes. Okay. Yes, thank you very much for that comment. This is the reason why we have proposed to use various means of reaching out. We during our sprayer calibration, hands-on sprayer calibration, we would be addressing the common errors that maybe applicators use, and we would be providing guidance for best ways to calibrate a sprayer, and we'll be addressing questions that people have and so forth. We plan to use the hands-on calibration and also the expert system application workshop to provide instruction and also guidance for best use of the system, and also proper setting of a sprayer in order to increase effectiveness of an application, for instance. I have one comment here that I can see growers using the system, but will commercial applicators take the time?
I think there are incentives. I think, especially if you hold workshops that have continuing education units, and they can sit with laptops or desktops and practice and work through it. But I think that person has a valid comment, a valid concern. Operators often, I think they already know everything, and I think we just have to start doing this and get the word out and sort of raise the bar and find incentives to raise the bar.
Yeah, and I believe that maybe not everyone gets on board initially, but as they through our dissemination, as we demonstrate the benefits of using this, I believe that it will catch up on people that maybe commercial applicators as well. We do not know, but as we engage, we would be able to answer some of these questions well. And at the end of the project, we hope to have made some impact in this area. I have a question here. Says maybe it's too ambitious. Would not it be nice to work on a sprayer with onboard computer with bunch of sensors to read the input parameters such as tree height, skirt height, foliage density, spray deposition, ground deposition, weather parameters, and so forth. Then adjust output sprayer configuration, maybe be self-propelled too. That is, yeah, I think that is true, and a lot of these new technologies are becoming available, but for some of the growers and applicators, the sprayers that they use are, don't have all these capabilities, and so the idea of using sensors to achieve this is possible, but we are looking at also getting down to the grassroots, where maybe a grower would not have the ability to, or does not have the means right now to have some of those sophisticated systems. And I think that we can combine both sensing and control, automation with the use of an expert system such as this, so people can actually take charge of what they are doing. Because one other thing too with the sensors is that based on my needs assessment, I realized that one of the challenges that maybe a grower would face would be how to maintain the sophisticated equipment, dealing with maybe breakdowns or maybe a component not working properly or something like that. These are challenges that have to be overcome. And while we have not been able to get to overcome these challenges, we also, I think it is good that we look at empowering those that do not have those systems with the right information, so they can take charge of what they are doing and be able to do it right. Thank you very much. And in this particular day of coronavirus, I think there is a push to as much as possible do some of these meetings virtually if it's possible. So we would thank you very much for that feedback. I would make use of this opportunity as much as possible to reach folks. Okay, I have a comment here. Say some applicators still using very ancient equipment, impossible to actually calibrate because of non-functioning gauges, etc. The expert system should illustrate how short-sighted such poor practices really are. Ineffective pest control is often attributed to poor material choice, timing. Real issue is the application. I agree with that. I agree with that. I always say that it's not a matter of what your gallons per acre is, but the issue is whether the spray is reaching your target. And there are things to do, adjustments to make on your sprayer that would make that happen. And so I agree with this comment, and would look at addressing it and including capturing that in the expert system. So are there any aspects you think the project should have focused on? What other activities or tasks do you think the project should have included? And then any other comments on how the project could better serve industry need? These are the questions we are looking at. And thank you for your comments. I hope we get some more feedback here.
I think some of the most important feedback you've gotten today is perhaps to break it up into, instead of one comprehensive, maybe have units that are geared for different audiences in terms of the level and depth of what it goes into. So I could see it having different units or different levels.
Yeah, that's right. That's right. Thank you.
It's a lot to take in all in one sitting. Sounds like there are no other comments.
I think that there are a few, I mean, there are a range of sprayers, and electrostatic sprayers are available from different manufacturers. I just don't know how much of it is being used. I know there are still questions that, as I talk to people, I have people ask questions about, whether electrostatic sprayers really work, and whether they're able to achieve the desired desired canopy deposition and so forth, based on what they are supposed to do, or they are designed to do. The air curtain sprayers and all that, I think these technologies have been demonstrated. The adoption, as I understand it, is that the adoption has not been wide, and it comes back to the idea of maintenance and being able to continue to keep the sprayer in a proper in proper function or proper working condition. But in terms of new technologies that are out there, there have been a few new technologies. One of the newest technologies is the autonomous sprayer that does the spraying without autonomous sprayer without an operator, and it's been showcased at different fairs and so forth, and I've seen it demonstrated online and so forth. But as it's new, I don't know how many people or how many growers have been able to purchase these or using these at the moment. But in terms of sprayer technologies, there are a few technologies that are coming out. Some of them are sort of some of the old things that are being reinvented, or old ideas that are being extended to to come up with new technologies and so forth. Do we have other comments?
I think you have your feedback.
Okay. So I think we have quite a number of comments here. I've gone through some of them. We have not been addressed them very very much in details, but we'll be looking at these. And again, you have my contact information in the meeting invitation that I sent to you. And so if you need to get back to me, with some feedback or some questions, please feel free to contact me, and I would do my very best to get back to you as soon as possible. It's 10:59 right now, and we have just about a minute to go. Are there any final comments or questions?
Thank you, Peter.
Thank you very much. Thank you very much for your audience, and thank you very much for the feedbacks, and thank you for your questions as well.
Okay, thanks for having us.
Thank you. I would end the meeting right now. Thank you.